Hello friends, welcome to our Mathematics Grade 8 Student Support Program. Our topic for today is surface area and volume. We will be dealing with 3D shapes. So the learning outcomes for this video are to demonstrate an understanding of a net of a cube and a cuboid, to recognize that the total surface area of a cube and a cuboid is the sum of the areas of all the faces of the nets, and to develop and apply formulae to calculate surface area of a cube and a cuboid. In the next videos, you will learn how to develop and apply formulae to determine the volume of a cube and a cuboid, to solve problems involving surface area and volume of cubes and cuboids, and finally, to fit cubes, cuboids into other cubes or cuboids. So let us start. Like I mentioned earlier, we are going to deal with 3D shapes. What are 3D shapes? So in previous grades, you have learned about 2D shapes where we have two dimensions. We have the length and the width. Whereas in 3D shapes, we will have 3 dimensions. We shall have length, width, and height. Some examples of 3D shapes are given in this slide. So you have examples of cylinders, cubes, cuboids, cones, pyramids, spheres, hemispheres, and triangular prisms. However, we are going to look into cubes and cuboids only in this chapter. Let us consider some real-life examples of 3D shapes. So where can you see 3D shapes in our everyday life? For example, this is a can of soup which is in the shape of a cylinder. You have a box of cereal which is in the form of a cuboid. These are boxes of pizza, which are also in the shape of a cuboid. You have a chocolate box, which is in the form of a triangular prism. Here you have the pyramids of Egypt, which are in fact pyramids. And you have a Rubik cube, which is in the form of a cube. So these are shapes that we see in our everyday life, and which are in fact real-life examples of what we call the 3D shapes. So for today's lesson, we are going to look at the surface area of cube and cuboid. What is surface area? The surface area, or the total surface area of a solid, is the sum of the areas of all the faces of the solid. For example, industries make use of total surface area to ensure that they have enough amount of packaging for, let us say, cereal boxes, washing powder boxes, or even boxes of juice. We also make use of surface area to ensure, for example, we have enough wrapping paper to wrap a gift. Now, surface area in real life. So these are some pictures for you. Wrapping paper for gifts, for chocolate, or even glass used to build an aquarium. So these are examples of surface area. Now we move on to a cube. What is a cube? I'm sure you will remember that you have already covered this in previous grades. Let us look at some real-life examples of a cube. These are cubes which we use in our everyday life. Let us consider a cube. This is the picture of a cube. So you will recall that in previous grades you have learned that a cube has 6 faces. It has 8 vertices and 12 edges. In fact, we say one vertex, but many vertices. So let us demonstrate what we have just learned. Here is a cube. In fact, it is a die which is in the form of a cube. And where the numbers are written, these are what we called faces. So we have 6 faces in all. 1, 2, 3, 4, 5 and 6. And each face is in the form of a square. Now, these are what we call corners. In fact, in mathematical language, we call these vertices. We say one vertex, but many vertices. So we can see that we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. Now, these are the edges. Let us see how many edges we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 edges. So we make a recap. We have 6 faces. Each face is in the form of a square. We have 8 vertices and we have 12 edges. Now, let us consider the net of a cube. What is the net of a cube? A cube, if I open it, I'm going to have different faces. This is the example of a net. You have a link here, which is very interesting. I would advise you to go and check this link as it would help you to better understand the concept of a net. This is a screenshot of the link. So, you have different possibilities of nets which are on the screen, and you can click on the different nets to find out whether when you close it you get a cube. So this is one possibility. You are asked whether a cube can be formed from this net. So if you look at the answer, no, a cube cannot be formed. A second possibility of net. Now this one, when I'm going to close it, I can obtain a cube. So it would be very interesting for you to try and check the different possibilities of nets, and you will see how the net can be closed to obtain a cube. And in some cases, cubes won't be obtained. Now we move on to the surface area of cube. Let us now consider how to find the total surface area of a cube. So you have a picture of a cube of length L centimeters. So remember, a cube has 6 faces and each face is a square. So area of one face of the cube will be in fact the area of a square, and you have learned in previous grade that area of square is length times length, that is L square. Now the surface area or the total surface area of a cube will be the area of the 6 faces, that is 6L square. Let us consider an example. Find the total surface area of a cube of edge 3.2 centimeters long. So the total surface area of cube is the area of 6 faces, that is 6L square. And in this question, L is in fact equal to 3.2 centimeters. So we are going to have 6 times 3.2 times 3.2, which gives us 61.44 centimeter square. We now move on to example 2. The total surface area of a cube is 864 centimeter square. Find the length of the edge of the cube. So the total surface area has been given as 864 centimeter square. Remember, the surface area of a cube consists of area of 6 faces. So the area of one face of cube will be 864 centimeters square divided by 6. So the area of one face will be 144 centimeters square. That is, the area of one square is 144 centimeters square. So to find the length of the cube, we need to take the square root of 144, which gives us 12 centimeters. We now move on to example 3. A cubical box of length 2.1 meters is to be made with cardboard. Cardboard is sold by square meters, with 1 meter square costing 20 rupees. Part A. What is the total area of cardboard to be purchased to make the box? Part B. Find the total cost of cardboard purchased. So let us have a look at the solution. Part A. The total surface area of the cube will be 6L square. Here the length is 2.1 meters. So we shall have 6 times 2.1 times 2.1 meters square, which gives us 26.46 meters square. Part B now. The total cost of cardboard purchased will be, remember in the question we were told that 1 meter square costs 20 rupees. So for 26.46 meters square, it will be 26.46 times 20 rupees. And this gives us 529.20 rupees. We now move on to some exercises for you to practice on surface area of cube. So you have a first question where you're asked to find the total surface area of each of the following cubes. We now move on to cuboid. What is a cuboid? A cuboid is also called a rectangular prism. So you have here an example of a cuboid. It has 6 faces, 8 vertices, and 12 edges. However, all the faces are not equal, as in the case of a cube. So let us consider a real-life example of a cuboid. So you have the cuboid here. We have again 6 faces, 1, 2, 3, 4, 5, 6 faces. But you can see that the faces are not equal. And we have 1, 2, 3, 4, 5, 6, 7 and 8 vertices. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 edges. Now we look at some real-life examples of a cuboid. You have an example of a matchbox, of a block, and you even have an example of a box. We now move on to the surface area of a cuboid. Consider this rectangular prism or cuboid. If I open this cuboid, I'm going to have a net. You can see the picture of the net. Now, let us consider this object. This is the cuboid which we had considered before. You can see that this is a rectangle and I have a similar rectangle here. This is a second rectangle and I have a similar one here. In the same way, I have a rectangle here and a similar one here. So these two rectangles are equal, these two are equal, and these two are equal. Let us now continue. So you have a picture of the different rectangles in the net, which have been labeled as A, B, C, D, E, and F. This is the picture of the net, and we have just seen that it consists of 6 rectangles. So the area of the net will be area of rectangle A plus area of rectangle B plus area of rectangle C plus area of rectangle D plus area of rectangle E and plus area of rectangle F. This gives me area of rectangle A is 3 times 5. Area of rectangle B will be 8 times 3. Area of rectangle C will be 8 times 5. Area of rectangle D will be 3 times 5. Area of rectangle E is 8 times 3. And area of rectangle F will be 8 times 5. So, simplifying, I get 15 plus 24 plus 40 plus 15 plus 24 plus 40. That is 158 centimeters square. So we say that the surface area of the cuboid is 158 centimeters square. In fact, the surface area of an object of a cuboid will be the sum of areas of its faces. So you have the same picture here, A, B, C, and the different rectangles. When you open, you get the net. Like I said earlier, we have 2 similar rectangles to A, that is A and D are same, B and E are same, C and F are same. So it's going to be 2 times area of rectangle A plus 2 times area of rectangle B plus 2 times area of rectangle C. In fact, if you have a length, width and height of a cuboid, the surface area will be given as 2 times length times width plus 2 times length times height plus 2 times width times height. Or simply this formula where L represents the length, W represents the width, and H the height. Let us now go back to the example of a box. So if this is the length, this is the width, and this is my height, I'm going to have 2 rectangles like the one at the top. So it's going to be length times width, 1, 2. If I consider this one, I'm going to have length, height. I have 2 rectangles, so it's going to be length times height. And here I have 2 similar rectangles where I have width times height. So the surface area will be 2 times length times width plus 2 times length times height plus 2 times width times height. We now move on to an example. Find the total surface area of the cuboid given in the diagram. So if we consider this example, we see that the length is 20 centimeters, the width is 8 centimeters, and the height is 3 centimeters. So the total surface area will be given by 2 times L times W plus L times H plus W times H. So now I just plug in the different values to find the total surface area. So I have 2 into 20 times 8 plus 20 times 3 plus 8 times 3 centimeters square, which gives me 488 centimeters square. Example 2. The total surface area of a cuboid is 700 centimeters square. Find the height of the cuboid if its width is 10 centimeters and its length is 15 centimeters. we have a look at the solution. So we have already been given that the total surface area is 700 centimeters square. That is 2 into L times W plus L times H plus W times H gives me 700 centimeters square. We have been given in the question that L is equal to 15 and W is equal to 10. So I replace these values. Simplifying gives 25H equal to 350 minus 150, which is equal to 200. So H will be 200 over 25, which gives me 8. So the height of the cuboid is 8 centimeters. We now have some exercises for you to practice. So question 1, you are given different types of cuboids and you need to find the total surface area of each of them. Question 2, let us consider now what we have learned in this video. So if we have a cube of given length L centimeters, the area of one face will be L square centimeter square, because remember, a face is in fact in the form of a square. So the total surface area will be the area of the 6 faces, that is 6L square centimeter square. For a given cuboid of length L centimeters, width B centimeters and height H centimeters, the total surface area will be given by 2 into length times width plus length times height plus width times height, centimeter square. You also have some links where you can practice some additional questions. For the first one, it is a game where you will have to identify 3D shapes. So friends, we have reached the end of the first video on surface area and volume, where you have learned how to calculate the surface area of a cube and a cuboid. You have also learned how to find the net of a cube and a cuboid. So until we meet next time, it's goodbye.